In this video I'm going to talk about operations on functions. Uh, so if we have two functions, f and g, then we're going to be able to create new functions by combining the old functions. And the new functions we're going to talk about is a function called f plus g, a function called f minus g, a function called f times g, and a function called f divided by g. The way we're going to do this, it's similar just to the way you would add, subtract, multiply, and divide real numbers. So we're going to define these new functions as follows. The function f plus g, which will have an input of x, will just come from adding the outputs f at x plus g at x. F minus g, not surprisingly, defined very similar, is just f at x minus g at x. F times g at x is just equal to f at x times g at x, and f divided by g at x, surprise surprise, is f at x over g at x. Okay. So really these functions, the way you get these new functions f plus g, f minus g, f times g, f divided by g, is you just perform the normal operations of addition, subtraction, multiplication, division on the outputs of these functions. One thing that's going to be important is the domain of these functions. So I'll just write the domain of each one over here. So look at this function, f plus g. So what you're going to have to do is add f at x and add g at x. So you're going to have to be able to perform you're going to have to be able to perform f at x and g at x. So this value of x must be in the domain of f and g in order to do both these things. So the domain of this function is going to be the domain of f intersected with the domain of g. So what that means is the domain of this function is going to be all the numbers that are in the domain of f and g. Same applies for this function, and this function. There's one exception for division. You're going to exclude the case where g, except when g at x is equal to 0. So the reason g at x cannot be 0 is because then you'd be dividing by 0, which we all know, not allowed. Okay, so now let's look at an example where we do this, where we combine functions. So let's say if f at x equals square root of x plus 2, and to go with g at x equals root 5 minus x. So now let's try doing some stuff with this. Let's evaluate f plus g, well, it's at 1. Let's evaluate f minus g at whatever, 0. And that's good. Just evaluate these two. Okay, so if I want to evaluate f plus g at 1, I have to remember the definition up here of f plus g. All it means is that I add f at x and add g at x. Well, in this case, x is 1, so all I'm going to do is add f at 1 plus g at 1. So f at 1, I'll take this function here and I'll evaluate it at 1, plus g at 1, so I take this function and I evaluate it at this function here, and I evaluate it at 1. So square root of 3 plus square root of 4. Well, square root of 3, I'll just leave it as that because it's not an exact square root. So I have root 3 plus 2. That's it. That's all I can do. That's all you can do without rounding, and then you would lose accuracy, so we'll stop there. F minus g, I'm just going to do the same way. So f minus g at 0. So I'm going to take f, evaluate it at 0, plus 2. And I'm going to take g and evaluate that one at 0. So I'm going to have root 2 minus root 5, and that's the best I can do. So that's f minus g at 0. You could also be asked to do something like this. That would be b, wouldn't it? Let's look back at those functions. So for b, let's say what is f times g? You don't need the dot. I just put the dot to just make it more obvious. So f times g at x. So here I want to come up with the equation. So all that means is we know from the definition. Here I won't put the dot. So fg at x is just equal to f at x, g at x. So all I'm going to do is take the formula for f at x, which was root x plus 2, and multiply that by the formula g at x, 5 minus root x. So root x plus 2 times root 5 minus x. That's the formula, f times g at x. I can't really do anything else with that. You can't simplify that too much. So it's not a nice looking formula, but there it is. That's the formula. And C will be what is the domain of one of these. It could be anyone. What is the domain of f plus g? You could do f minus g or f times g. They're going to have the same domains. So I'll just rewrite f just so we have it. So remember, f was root x plus 2, and g was root 5 minus x. So remember, our definition said that it's going to be all values that are in the domain of both. So what we're going to have to do first is determine the domain of each one of these. So the domain of f. The way we're going to do that is the domain of f is when the square root will occur when the square root is positive or equal to 0. So everything under the square root has to be bigger than or equal to 0. So that means x plus 2 has to be bigger than or equal to 0. Subtracting 2 from both sides means x has to be bigger than or equal to 2. So the domain of f is the set of all x such that x is bigger than or equal to 2. Negative 2, sorry. Do the same thing over here. So the domain of g occurs when everything under the square root is bigger than or equal to 0, which means negative x is bigger than or equal to negative 5. Dividing both sides, actually don't do that. Divide both sides by negative 1, you'd get x, and then we have to switch the signs, is bigger than or equal to positive 5. Which means the domain of g is the set of all x such that x is smaller than or equal to 5. So the domain of f plus g will be all the x's that are in both these sets. So now we want to intersect domain of f intersect with domain of G. So that's going to equal the set. I'll write it over here. That will be the domain of f plus G. Right? This is what we said. So now, how do you intersect two sets? Sometimes it helps to think about the number line, just to visualize it. You don't have to do this, but you can. So the domain of f was all values bigger than -2, and the domain of G was all values smaller than 5. So there's 5. So the domain of G, including 5, was all values going this way. Down, 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 down to infinity. The domain of f, sorry, this was the domain of G, was all values bigger than or equal to 2. So all these values. So basically, everything, the values that are in both go from -2 to -5. So the intersection of these two sets is a set of all x, such that x is bigger than or equal to -2, and smaller than or equal to 5. That's the worst set symbol I've ever seen. A little better. Okay, so that's how you determine the domain of a function that's been added together. Actually, let's just do one more. What about the domain of what is domain of f divided by G? It's almost the same, right? Remember, f divided by G it's the intersection of the two sets, but we have to remember that G at x cannot be 0. So you would just determine where is G 0. So when does G at x equal 0? So since G at x cannot be 0, we'll find when G at x equals 0. And if you remember, G at x was root 5 minus x. So when does that equal 0? Square both sides. 5 minus x equals 0, which would mean x is equal to 5. So we need to take out this value when x is equal to 5. So we had said x is all numbers between -2 and 5, including -2 and 5, but now we're not allowed to include 5. So the domain of f divided by G will be almost the same. It's from -2 to 5, but now we're not including 5, so I don't have the equal sign, because from this, that means x cannot equal 5 for the domain. Right? So you find when it does equal 5, and therefore x cannot be that value.